There you go. I believe that a facility's goal is to provide a safe and code-compliant building. And in conjunction with that goal, I believe on construction and maintenance projects, and even renovation projects, minimizing schedule delays, cost overruns, engineering judgments, and code compliance citations is equally important. And when I work with facilities and working with Mike, this is what I have in mind in working with clients, and I believe in establishing an effective barrier management program. This should always be the goal. Okay. Now, the model or blueprint to attain this goal, I believe, requires three components. And this will be the outline as to what we're going to go through today. Number one, why is fire stopping important? The how question is next. How to get to where you want to be, where we want to be. And finally, what steps are necessary to implement to get there? Why, how, and what? One other thing I think I want to mention in this particular webinar, we will not be mentioning product. This is not a STI product infomercial, okay? A lot of times you've sat in on fire stopping presentation and it's camouflaged as a fire stopping product infomercial. No products will be necessary because in the barrier management program, I think these are the three questions that need to be asked. So why is fire stopping important? Well, it's a life safety issue. We'd all agree with that. It's a code requirement. And third, as a code requirement, it's non-negotiable. Wouldn't you agree, Mike?
Yeah, Mike, from the facilities director standpoint, I think number one, always as a facilities director, we're worried about patient safety, right? Number two, we're worried about our staff, the people that are providing care. And I think that's why it's important to us here at Loyola.
Sure. Hey, now consider all life safety building materials required by code. And we know what they are. Okay. We'd never think of asking an electrician about dampers or a sheet metal contractor about sprinklers. Mechanical contractor about structural steel fire protection. Why? Because every one of these items is installed by somebody who's licensed or trained in that particular field. I was talking to a facility director this morning and I said, when they're doing your electrical work or their plumbing work, you're assuming they're doing it according to code, correct? Mm-hmm. I mean, right? I mean, you would never say, do whatever you want. Unfortunately, it's been our experience in fire stopping that whole code requirement, they want to do it correctly, but they don't, but a lot of education and training isn't going into really understanding the code requirements for fire stopping.
Absolutely. I think people want to do the right thing. I think it's that they're not always educated on the proper installation. So, they think that a tube of caulk will get you where we're going. And I think that's why a partnership and a barrier management program is important.
Sure. Yeah, because fire stopping is different. It's installed by every trade. No single trade takes ownership. No licensing is required. Few properly trained installers and a few special inspections. And healthcare. Healthcare is unlike any other niche in construction or in any type of building. Why? Well, there's more penetrations than in commercial construction. There's more different types of barriers. And as you well know, Mike, especially with low voltage cables, there's constant changes, correct?
Sure, there's always somebody in our ceiling, right? It's not only my staff, contractors, it could be fire alarm staff, it could be IT, it could be low voltage, it could be cameras. There's a lot of people entering our ceilings, making penetration in our barriers.
Sure, and as we say here, unsealed penetrations are one of the leading cause of environmental care recommendations by Joint Commission. As a matter of fact, you can go back year after year, and according to ASHE, the number of fires, the percentage of fire stopping violations are just unreal. And if something's not done correctly, Mike, who's responsible?
We're responsible.
Engineering is always responsible. Okay. So let's talk about the code requirements. We said, why do we fire stop? We said it's life safety. We said it is a code requirement. We have on the screen the different code references, whether it's IBC, NEC, plumbing code, IMC, NFPA, you name it. It is a code requirement in every one of those, in every one of those areas. Now all those model building codes require fire and smoke protection. Now we're all familiar with fire protection requirements, and they are well defined, but also the smoke and leakage requirements have also been clearly defined. And these, in the IBC, and it's typical of all the other codes, there are various sections that address how you address fire barriers, smoke partitions, and how you address the penetrations through those barriers and partitions, and also those joints. You know, like one of the things that comes up regularly when working with contractors, working with facilities, is the whole idea of them coming back to me and saying, oh, that's a smoke wall. Mm-hmm. And I said, well, you know, really, that doesn't give me a lot to work on, because there is no such thing as a smoke wall. It's either a smoke barrier or a smoke partition, and they have to be treated differently. Now, the building codes, as we said, they are the laws, and the openings and barriers must be restored. I want you to look at the second one. It says fire barriers. Fire barriers have to be treated with third-party tested systems. And for ease of discussion today, the third-party tested system, the third-party tested organization we'll refer to as Underwriters Laboratories. So everybody's understood that we have to treat our fire barriers with third-party tested systems. Okay. Next, we get to the smoke barriers and the smoke partitions. If that barrier has been deemed to be a smoke barrier, it too has to be treated with a UL tested design. A smoke partition doesn't have to be treated with a UL system design, but it must be treated in a manner to seal the gap and the openings with an approved material. So that's one of the big things we have when we go into a facility, because they're saying, oh, that's a smoke wall. Now, the one thing you don't want to do is to treat your smoke barriers like smoke partitions. And then when a authority having jurisdiction comes in and says, well, that's not right, and then you might have to do some remediation work, which could become very costly. Then the third-party tested system standards are right below. The penetrations have to be treated on both smoke barriers and fire barriers with tested designs tested to either ASTM E814 or UL 1479. And the joints have to be treated to ASTM E1966 or UL 2079. That would be for the fire barriers and the smoke barriers. I tell a lot of facilities, I says, the key word here is barriers. If the designer has determined that it is a smoke barrier, treat it just like a 1-hour fire barrier with a UL system design. And if it's a smoke partition, you don't have to have that degree of protection. It just has to utilize a smoke and sound caulk that can prevent the passage of that smoke. And this gets into further detail in section 709 for the smoke barriers, where it says, according to 709, it needs a 1-hour fire rating, and the penetration should be treated in exactly the same manner as you would treat a fire barrier. And then section 710 tells you that the smoke partitions, unless required elsewhere in the code, are not required to have a fire resistance rating and can be treated with a smoke and sound caulk. Have you found that to be a problem with some of the kind of work that's being done?
Absolutely, Mike. You know, the one thing that I could add here is the importance of having a subject matter expert like yourself by my side. we have so many responsibilities as a facility director to know code, to keep the operation, moving forward, putting, more and more on facilities directors every day. I really need a subject matter expert that I can reach out to that's going to help me get where I'm going to take this barrier management program to the next level.
Well, I like to say Loyola has invested in STI, and STI is investing in Loyola and everybody else who's invested in us. Now, we talked about why we fire stop. The next question is the how question. How can we get to where we want to be? So before we can even begin to think about establishing a barrier management program, we need to address two areas: education and training. A lot of people say, oh, education and training. Education and training is more than just sitting in a 1.5 hour presentation and getting a certificate. I think education starts with the fire stop theory. What exactly is fire stop? What I'm showing you now here are some slides, some actual installations. Okay? Not in the Chicagoland area, mind you, but actual installations. And here's my favorite. And the question I always ask when I present situations like this to the attendees, I says, why do you think this happens? And I'll tell them, I think I know why it happens. I think when you talk about fire stopping, you're focusing on the product. You're focusing on the product. As if I said earlier, the fairy godmother put foo-foo dust in the caulk tube, and no matter where you put it, you're going to receive a degree of rating. And the more product I use, the greater the rating I have. And I believe that if you focus on the product side of fire stopping, you're forever going to be frustrated. Because fire stopping should always be focusing on the barriers that comprise your building. Okay? Which brings us to the whole idea of compartmentalization or compartmentation. Okay? I ask people, I says, I get questions all the time. They say, Mike, should that be a 2-hour wall? I says, I don't know. That's not my job. That is the designer's job. Based on the size and the usage of the space, they decide what the rating of the barrier should be and which barrier should carry a rating. I also say in general, we can assume that every floor carries a rating, but not every wall does, okay? And the whole idea is if an incident, so what we've done is we've compartmentalized our building. Or in this case, if we look at the graphic on the left, we have various compartments. Each of those, instead of saying 1, 2, 3, or 4 hours, we'll just say, for ease of discussion, we'll just call them 2-hour barriers. Okay, each compartment there is a 2-hour barrier. Now, with the whole idea of compartmentation, if we had an incident that breaks out in the compartment on the right, we would want that barrier to be effective for 2 hours. I says, what would happen after 121 minutes? Well, they says all bets are off. If I wanted 3-hour protection, I would have constructed 3-hour barriers. Now, if we look at that graphic on the right, we'd have to say that's not realistic, right? I mean, we want air conditioning, we want to turn our lights on and off, we want to flush our toilets, right? Which means we are going to have penetrations. And once we have a penetration through a rated barrier, that rated barrier has lost its degree of protection, its rating, if you will. And then, like on the left, that was a 2-hour compartment. Once the barrier has been compromised by a surface being routed through it, no longer carries a rating. And in the event of an incident, like it shows on the graphic on the right, okay, that incident, that fire, whatever it is, gas leak will go from zone 1A to 1B. So fire stopping, as I said, should not be focused on the product. Fire stopping should be focused on the barrier. Fire stopping is nothing more and nothing less than sealing the opening to restore the hourly rating of the barrier that has been compromised by a service being routed through it. That's fire stopping. That's the fire stopping theory, away from product toward process. So where is fire stopping required? Okay. Fire stopping is penetration fire stopping is defined by Underwriters Laboratories. And you can read that, but I'll read it for you as well. And I hate reading slides, but it says fire stop systems, which are specific constructions consisting of a wall or floor assembly, a penetrating item passing through an opening in the wall or floor assembly, and the materials designed to prevent the spread of the fire through the openings. Notice, we're going to get into this a little bit later in the presentation. There are 3 components that are addressed in every penetration fire stopping design. The wall or the floor, the penetrating, the assembly, I should say, the penetrating item, and finally, the fill material. So where's fire stopping required? First and foremost, what most people are familiar with is a through penetration. A through penetration is nothing more, nothing less than a penetration that goes completely through the wall or the floor. And it could be metal pipe, PVC or combustibles, cable bundles, cable trays, insulated pipe, busways, ductwork, or I call it the Jeopardy category potpourri. You put the metal pipe and an insulated pipe and a cable through the same opening. Lots of different types of penetrations in your facilities, right, Mike?
Absolutely.
The next, there'll be membrane penetrations. Membrane penetrations would be penetrations typically in a rated gypsum wall cavity where the penetrations come up through the cavity and maybe just penetrate one side to feed a lavatory, okay, or a water closet, or a conduit just coming out of one side. The question is, if the barrier is both sides of that wall, if it goes through completely through both sides or just one side, the barrier has been compromised. Another point that needs to be addressed is where we see the putty pad on the back of the electrical boxes. Time constraints do not allow us to go through something like this because this would address also not only electrical boxes with putty pads, but recessed med gas boxes in rated walls, or electrical cabinets through rated assemblies. Where else? Joints. Joints. Where a rated wall meets a rated deck, or a control joint in a CMU block wall, or an expansion joint in a floor. Remember, what we're trying to do is have that incident be contained in its area of origin. So not only do we have to treat the penetrations, but we have to treat all those joints. I mean, nobody installs a control joint in a CMU block wall and says, boy, I think that would look good. Okay? Nobody takes their gypsum wall or their CMU wall tight to the deck. Okay? There's always going to be a gap. And think about this, fire goes up, correct? And if those joints are not sealed at the head of the wall, it's going to waterfall, bad pun, waterfall, the fire is going to waterfall over into the next zone. In the last area of where fire stopping is required for today, as far as we're concerned today, is perimeter containment. Slab edge protection, where the concrete slab of the building meets the exterior curtain wall, where you have a rated assembly, okay? A joint between a rated assembly, meaning the floor, going to a non-rated or unrated exterior curtain wall. So that's where fire stopping is required. Anything to add, Mike?
Yeah, Mike, all of these designs are pointing to maintaining the rating of that room. And why are we keeping the integrity of that room? We're protecting a patient that can't protect themselves, right? Healthcare has the highest level of fire rating. We're the only business that defends in place. We can't move these patients. if we do have an event where we do have a fire, the best thing we do is close the door and contain, right? Because we're going to let the smoke detectors set the alarms off. We're going to let the sprinklers do their job. If we can keep that fire in that room, that sprinkler is going to snuff that fire out, and that's the best case scenario.
Yes. Now, this happens to be my favorite slide, my absolute favorite slide. I look at this and I say, okay, that's a 1-hour drywall assembly. What it is not, it's not 30 minutes on one side, 30 minutes on the other side. That whole barrier right there is 1 hour. And on the right, we have a fire. When we have an incident, like in the zone on the right, we go from an ambient temperature of 75 degrees to 1,000 degrees in the first 5 minutes. At the end of 1 hour, it will reach 1,800 degrees, and it will continue to increase in temperature the longer that fire is
Correct.
is going.
Fire doubles every minute.
Right. So at about the 45-minute mark, remember this is a 1-hour assembly. At about the 45-minute mark, some strange things happen, and eventually that hot side face of that barrier is going to be compromised, and now that fire is going to be dancing inside that cavity, attacking that cold side face. And if we lose that cold side face before 1 hour, okay, we have a failure. That's why the toughest barrier to achieve a rating is a 1-hour drywall assembly, because we only have one layer of drywall protecting that cold side and that hot side face. Okay. So I always ask a question: if we had a penetration through this wall, do we have to caulk both sides? And people say yes, and I say to them, no, just tell me what side the fire breaks out on and we'll just do the other. Well, then they laugh, but that's the whole point. You don't know what side the fire is going to break out on, so you have to do both sides of a wall, whether it's a CMU block wall, a concrete wall, or a gypsum wall. The next question is floors. I ask them, what's the hot side of a floor in a fire? And if you think about it, if you were on the 5th floor and there was a fire on 4, you would be in more danger than the person who was on 2, because fire goes up. So the hot side of every floor is always the underside. Always the underside. That's why if we look at the UL system designs, we caulk both sides of walls, and in most cases, we caulk tops of floors. Now there are exceptions. Some of the larger PVC pipes or larger insulated pipes we might have to treat from the underside. If we're on a renovation project and we don't have access to maybe the 5th floor, we might have to caulk the underside. Hollow core precast, we might have to caulk top and bottom to seal off the cores. And in 4-hour assembly, sometimes we have to caulk both top and bottom. So how is fire stop tested? It is tested according to these standards, through penetrations, according to 1479, as we mentioned earlier, or 2079 for UL, for joints. And those are the accompanying ASTM standards, very similar. And there's also standards for curtain wall curtain wall treatments. And every time, now let's talk primarily about through penetrations. Whenever we are testing a through penetration condition, we publish systems with various ratings: an F rating, a T rating, an L rating, a W rating. Let's go into these just briefly. The W rating represents the minimum amount of time that a fire stop installation has been tested and shown to prevent the propagation of the fire. What does that mean? If somebody has a 2-hour barrier, you need a penetration system with a 2-hour F rating. Okay? So the F rating typically is going to refer to the hourly rating of protection we're looking to achieve. There's also a T rating. Every through penetration system has a temperature or an insulation rating. Okay? Now, we don't always have to have a matching F rating and a T rating, but we test for both an F rating and a T rating on every one of our through penetration tests, along with our joints. Now in that test, we look for the time it takes for a single point on the non-fire side, the cold side, to reach 325 degrees above ambient, where ambient is 75 degrees. We're testing to see at what point that non-fire side reaches a temperature of 400 degrees. And what's really important there, at 451 degrees Fahrenheit, cotton waste can spontaneously combust. So what we find in most specifications and codes is that we don't necessarily have to have a T rating for our wall penetrations. But it is very, very important to have T ratings on certain floor penetrations. Certain floor penetrations. Because we don't want to have an exposed metal pipe, okay, where for 1800 degrees after 1 hour, and we have that metal pipe on that cold side face, it's going to be pretty hot, right? Absolutely. And if we stored linen or paper or whatever, a combustible material close to that pipe on the cold side face, we might have that incident now spontaneously combusting in the zone above. Now, where are the exceptions for T ratings? Obviously, if that metal, if those penetrations are within that stud cavity, they're going to be protected. Or drains in concealed space of horizontal assemblies, or if we have maximum 4-inch conduits penetrating the floor, entering an enclosed metal enclosed switchgear cabinet, correct? We can also have L ratings. L ratings measures the amount of air leakage through the penetration. L ratings are going to be very important when we're dealing with smoke barriers. Fire barriers don't necessarily always have to have a T rating, and they don't have to have an L rating, but smoke barriers have to have that 1 hour F rating, and they have to have an L rating. Okay, and finally, we can have W ratings. W ratings allows primarily floor penetrations to withstand water going from one floor down to the floor below. And typically we use silicone-based products for that. Now that's not to say if you want a W rating, just throw in a silicone-based product. Just means we have to find a UL system that gives us that W rating. And the directory will have all of these different recipes on how to treat different types of penetration seals. And as I said, these are the recognized and accredited third-party testing facilities. We primarily use Underwriters Laboratories, but the other two, Intertech and Factory Mutual, are also approved third-party testing facilities. This just tells us a little bit about how FireStop is tested. As you can see on that floor mock-up on the right, we have thermocouples to measure that temperature rise. Okay, and as I said before, if you look on the graph on the right, we go from an ambient temperature to 1,000 degrees in 5 minutes, and then we start ramping up based on what the temperature criteria is at 1, 2, 3, and 4 hours. And when they test these penetrations, Mike, they follow this time temperature curve to see what the heck happens. After the test, you can see that if no flame or smoke passed through the penetration during the test, we're then going to hit it with a water hose stream test to test the structural integrity of the fire's stopping treatment. And if it passed the flame, the smoke, and the water hose stream test, you're successful. And then, however you treated that penetration seal, that recipe gets inserted into the directory. And then when your people are doing their penetration seals, if they can reference that design for that condition, you know it's been done properly. Make sense, Mike?
Perfect sense.
Mm-hmm. Okay, so what is a UL classified system? We talk about UL. Well, Well, a UL classified fire stop system has three components. They include the fire rated wall or floor and the opening created in it, the penetrating item, and the fire stop fill material. Notice the fire stop fill material, I'm not saying fire stopping product is not important, but it is just one component of treating your penetrations and your joints properly. What we've come up with is, and you're familiar with this, Mike, we provide this to the contractors who work here, we provide these to you. This happens to be a worksheet that we have developed over the years. We developed this worksheet over 20 some odd years ago when they were building Stroger Hospital. And the IDPH has adopted somewhat of a model like this where they call it for the Book of Solutions. But my colleague, Mike Jevney, who's the territory manager for this area, has worked and put together worksheets for various types of trades. This would be for electrical trades through concrete barriers. It would be one for electrical trades through gypsum barriers. And if you kind of look at this, we do ask the 5 questions. What's the through penetrant? What's the assembly penetrated? Is the presence of insulation and sleeving, the hourly rating, and then the UL design. And the UL design tells what product to use, and it gives all the parameters that need to be. So if in this example, if I was looking at a single conduit through a gypsum wall, Mike, I would use WL 1222. And WL 1222 would be the recipe that I would use to treat that penetration. And how about labeling? You like labeling? You need the labels. Why? Got to know what they did. It's not just, the inspector is never just inspecting caulk, right?
Correct.
We also have work scheduling worksheets for construction joints. And as you can see right here, there's a lot of different situations. You can have a head of wall, gypsum wall through fluted pan deck using a sealant, and the orientation of the flutes is in the perpendicular orientation on the right. And as you can see, this would be this is a nice reference tool to give you ideas for some of the penetration seals and construction joints treatments you have in your facility. You're all familiar with that. Now, the training component of how is equally critical. Remember, we said, why do we fire stop? Life safety and code requirement. How do we get to where we need to be? Well, we just went through the education part. And I think you would agree that the education is critical, Mike, because if they don't have the education, where are you?
Absolutely. And you know, that's why this presentation is important, is the more people that understand the why, the better off we are. It's not just facilities job, it's not just IT's job, it's not just contractors that are doing work in our facility. The more people that understand fire stopping, the better off our facility is going to be.
And along with the education, it's the training. The training component is equally critical. I believe that all trades performing fire stopping work should undergo the same degree of training. Yes, the people who are doing the fire stopping work should be trained. But I also believe the trades who have subcontracted that fire stopping work to, say, a third party should undergo training as well. Now, this ensures conditions that they are leaving conditions that correct UL systems can be installed. If I have a 4-inch pipe going through a wall, there are certain annular space requirements. Now, that contractor running that service through that wall may not be doing the fire stopping work, but boy, they certainly should leave that in such a manner that it can be done properly.
Correct. I don't want to see through penetrations that are feet larger than they need to be, right?
Right. And the last bullet point here, the goal is a consistent approach to fire stopping throughout the facility for both new construction, renovation projects, and maintenance projects. I think the goal of the facility is, no matter who's doing the work, maintenance personnel, fire stop specialty contractors, or the different MEP trades, that we're all doing it the same way. so that you know that fire stopping is being done the same way. And the only way I believe we can do this is through training. And I don't believe that training should be a 1.5 hour presentation, getting a certificate and saying I'm now a fire stopping expert. I think fire stopping should be something that should be regularly visited because things change. So what's next? We talked about the why we fire stop. We talked about how we get to where we want to be through education and training. So what's next? And it goes back to what I talked about earlier, which is focusing on the process rather than the product. I think for much too long, fire stopping has been product focused. Okay, I use this manufacturer's product and they're all the same. But as we well know, the jurisdictional authorities are a heck of a lot smarter today than they were 40 years ago when fire stopping started. And they're not just looking at product anymore. I always tell people they want to know what UL system you installed for those penetrations and those head of walls, because their job is not to figure out if it was done right. Their job is to figure out whether or not the installed system met the parameters of the tested design, which brings us to a topic called labeling. Now, labeling is not required by code, but how important is labeling at your facility, Mike?
Labeling helps us with surveyors. You know, when surveyors go up in the ceiling and they're seeing quality fire stop, they're seeing the same label from the same company. It has all the pertinent information. Well, they stop opening ceiling tiles, they stop surveying, and they move on to something else.
Right. I believe if they're inspecting, if they're doing a walkthrough, and they check 7 locations, and each location has a label and the proper UL design for that treatment, I think it's pretty safe for them to assume that everything's been done according to the same process.
I think they know that's true. They know that we take this seriously. I think life safety appreciates it, the AHJs appreciate it, and I hope that the patients and the staff appreciate that we're trying to protect their best interest.
Sure. I also believe at the time of contract award, I believe that you should insist on submittals for the fire stopping work based on the conditions present or going to be encountered on the project. I mean, if somebody says they're going to be doing the fire stopping, they should be able to provide you with something similar to the worksheets we showed that says, based on our takeoff, on our inspection of the work that we are going to be presented with, these are the conditions that need to be fire stopped, and these are the UL systems we propose to install. And I think failure to provide such documentation at the time of contract award may be a red flag as to whether or not, with respect to their fire stopping expertise.
You know, Mike, I like how you bring up present condition, because sometimes we discover conditions, right? And I want to work with contractors that are either going to help us repair those conditions, or they're going to bring that to my attention so I could repair it. I don't want people, you know, I made this hole here, but there's a hole next to it, and just walk away from that, right? Because that doesn't do me any good.
Sure. So what's next? I also think that in a fully functional barrier management program, there should be certain standard operating procedures that everybody who's working in the facility with respect to fire stopping should adhere to. And I think in a barrier management program, there should be standard operating procedures that if you're going to be doing work in my facility, you should abide by these, and you should sign off on this. And now this can ensure compliance for all parties involved in the fire stop activities. So it's also an accountability tool. If somebody signs off that they're going to abide by your standard operating procedures and be involved in your barrier management program, there's some accountability there. should probably make you feel comfortable as to what's going on, right? And finally, documentation. Documentation of all work performed should be provided by contractors performing fire stopping treatments. And I believe this then gives you archived material as to what was done.
Like the rule of thumb is if it's not documented, it didn't happen.
And I also believe that there are electronic programs now available that are preferred by a lot of facilities.
Absolutely.
Electronic programs that allow you to, you know, take a picture on a renovation project of before and after, or on a particular penetration seal. I have a picture of what it looks like. Here is the item number. Here is the UL design. It certainly makes your job a lot easier to have it electronically and instead of having a whole bunch of 3-ring binders, doesn't it?
Absolutely, a lot less weight to carry.
Mm-hmm. So, you know, fire stopping should always be process focused, always. And without the proper educational and training tools, fire stopping defaults to a product's focus. Invest in your facility. Invest in your facility and adopt the process over products approach. As I said before, we are invested in the facilities we work with because they've invested with us. And it's been nice to have you here, Mike. In the background is Mike Javney, who's the territory manager for this area, and he's wonderful. He's great to work with. But we have Mike Rerucha, Mike Bartkowski, and Mike Javney. If somebody says Mike, we don't know who they're talking to, but this is our information. If you saw anything here that you'd want to know more about, we'd welcome the opportunity to meet with you. And Don, we want to thank you for inviting us to present today. They said there were 61 slides. They says, Mike, you're going to get through 61 slides in an hour? I says, I won't have any problem. I says, I just don't think, I think an hour is too much. Yeah. And the last thing I like to do when I'm watching a webinar is to watch and say, okay, how much longer? Well, we're at the thank you slide here for thank you from STI, and thank you, Mike Rerucha, for participating as well. There's our information. We'll leave that up. But Don, I think we're done. And if there's any questions, we'd certainly welcome those.
Here's a question for you guys. Can you highlight the electronic programs you would recommend for documentation?
Call us.
Yeah.
Mike, how about you?
Yeah, you know, I don't want to name anything by name here, but we do use a couple of products, and I'll tell you what's nice is to have pictures and to have documentation to back those pictures up, right? We want to know the UL design, we want to have picture, and then preferably we want the location plotted on life safety drawings, right? So you have everything at your fingertips. I can tell a surveyor everything they want to know right then, right there.
Yes, and if they wanted to call myself or preferably Mike Javney, we can provide them with a couple of options available for electronic documentation. We just don't want to. Obviously, one of them is STI, and like I said, I don't want to be infomercialing you. But give us a call and we can talk offline, and you have our numbers there. But we'd be happy to do that.
All right, fair enough. Early in the program, there was a comment really given to us, and I think in the part of the program where we were talking about smoke specifically, yes. Someone did mention that there is also smoke resisting.
Sure.
Smoke partitions are actually defined in the building code and are typically 1 hour rated.
I think smoke barriers. It's always been my understanding that smoke barriers are treated as 1 hour rated and smoke partitions are treated as non-rated, but I might be wrong. All I'm concerned about right now in this particular presentation, Don, is how do we treat the penetrations associated with smoke partitions versus smoke barriers? okay? And I know that we treat the partitions differently, the penetrations through partitions differently than we treat the penetrations through smoke barriers.
Having said that, I want to thank everyone again who spent the last hour with us. And thank you to Mike Bartkowski and Mike Rerucha and Mike Jevney back there. It's been a blast. You guys have done a great program. I wasn't sure I was going to be able to make this work, having to deal with three guys all named Mike, but we did it. So
Yeah,
thank you.
and I want to thank Mike Rerucha for joining us, and obviously we're sitting in his office, and you know, being around him, we feel like big shots now, you know.
All right.
Mike, I'm just glad to be here, and I got to tell you, I'm glad to partner with a subject matter expert like yourself that has a passion for fire stopping.
And Mike.
And Mike, you've always been there for me at a moment's notice, and I think we've really taken Loyola to the next level from a fire stopping aspect.
Well, thank you, Mike. Don, it's 12:55, less than an hour. Thank you very much for hosting, and
My pleasure.
have a good day, folks.
Thank you for
Thank
joining.
you.
Yes. Have a good afternoon, a safe day.
You bet.
Bye-bye.
Bye now.